How to use the recurrent sequence calculator. It loads up with the fee scale parameters. To go ahead and calculate that one, you just click in one of these, click over here, out of it. That blurs the input. I didn't put a button on there. I wanted to do it a little different where that you blur inputs to cause things to happen. Anyways, that'll generate a sequence. That's the Fibonacci sequence. So you can start on any of these and pick a scale. Actually, you can select the scale size first that are MOS, moments of symmetry scale sizes with the converged generator. We'll do 13. And you could change the seed if you wanted to different seed types. Anyways, let's do the 13 one. You'd have to blur this input again to clear what's already on there. And then you can go with a different scale size, 13. And what that does is it makes a circle graph and a table. Then on the table you can select each of the rows and it shows you where the Fibonacci triplets are at. The pink ones are ones that have missing members. Okay, scroll on down and you have a lot of information. You can copy and paste and it retains the carriage returns. It's got the 1 over X zigzag. It's got that table up there. And it has the seed and the recurrent sequence scale in scale of file format. And then it also has converged generator MOS scales. It's running in a sub window, but it has all of them up to the 13 tone one. That's going to be, this one is approximating the 13 tone one, and the others are contained in those, but they're printed out just to be consistent. Okay, so you want to do another scale. Let's say you're reading Meru4.pdf and you find this one, g equals 1 plus g to the 6th to the 1/7. And you can look that up if you want. So g equals 1 plus g to the 6th raised to the 1 divided by 7. So you'd want to put that 7 in over here first, and then the 6th. And the others are pretty much the same. G equals 1 plus g. A would be 1. And 1 times g is g. And to the 6th raised to the 7th. 1 plus g is 6 raised to the 1/7. So, and with this one, we're going to select the new MOS size. It's kind of weird. We'll go with 22. And we'll go with the custom S seed. This is a seed helper. You put a number in here and then click outside the box and it calculates the seed for you. We'll see that 4, 5, 6, 8 is in there. That's an octave repeat and 16. So let's try 32. And your octave repeats there. Doesn't look like it. So let's try that. And then you look over here to see if there's any octave repeats. Yep, 7, 72, 25, 16. So 2 and 5, 50 and 100. Okay, so let's go up to custom SC. Let's go 64. Reselect the sequence. I don't see any octave repeats there. So there's that. Triplets are a little tight on, or tall triangles, skinny triangles on that one, but I guess it's all right. This would be like try a 3EDO approximating recurrent sequence. And you go down here and look, you could copy all this information again. So that's it. One of the things you want to look out for is when you're putting these numbers in, you want to do D first, because if you've got something bigger in C, it's going to lock up. And so you want to put the bigger one in first, D, then C, then B, then A, or A and B, either one. You can kind of play around and find different generators, or you can get the big list and put these in and play with generating different scales. All right, that's it. Thanks.